Next is Riverside, a network security visualization tool by Kaitlyn DeValk. Please.
Okay, thank you for coming. I know it's like right after lunch, so I hope everyone's like not sleepy from like food coma or anything. But yeah, I just want to talk about a tool that I built during my master's program that I just finished, and that I kind of just finished putting together and put up on GitHub, which I'll have all the links at the end. This is my first time talking at ShmooCon. We love coming to this conference, so thank you, yeah. So just a quick background, as I said, so I did just finish my master's at Maryland, but I'm actually in the Coast Guard. That is what my previous job with the Coast Guard was. I worked in a SOC, and I also did vulnerability assessments, which is kind of where like the inspiration for this tool came about, and I'll talk about that on the next slide. But yeah. So why a visualization tool? I got asked this a lot when people came up and asked me about my talk and like why I built this specifically. Something that when I used to go out and do assessments, and you know, you go ask like, oh, can I have like a network map or like an asset list, like, because we're going to go assess your system, you know, for our job. And half the time it was either non-existent or inaccurate, or I had to go find this one specific person that has worked there for like 40 years, and they're the only person that could tell me exactly what was what. And when we did start to do scans and stuff like that, it took us like days to figure out what was actually connected to what am I looking at? And especially when you're talking to maybe not someone that is the most technical, like having them understand that why that's so important for us to have that complete picture of like what's going on in that environment. So that's kind of what inspired me to build the tool that I'm going to talk about today, Riverside. So part of my master's thesis was actually talking to people in the community, asking them like, what would you want in a tool? Like, what do you need when you're talking about a visualization aspect? So that was something that was really important for me, was getting input from the community. So asking people like, what's the data that's important for you? What aspects of a visualization are important for you? What would you want to see? So these are kind of just some like very, very rough sketches that I had from people that randomly they drew up, and they were like, this would be cool if it could do this. So this person specifically was like, it'd be great if we had a visualization as well as like a table that matched that, to be able to show the raw data tables as well as the data that's being visualized. Another person was like, it'd be great if it slowly built out the network map. I know, this is a very, very rough, these are people's rough sketches on like MS Paint, okay? So, you know, this is not what the tool looks like. But like something that can start from one point and then grow out from that. So to be able to like grow and do that like dynamic discovery and be able to like show everything that's in that environment. Other people liked the mix of the, again, kind of like that information while you selected maybe a piece of the network. And other people kind of like that ability to like drill down into the data. So as you clicked one thing, it would show more things. Though not maybe showing everything automatically up front because of that like kind of idea of like burnout. Like seeing all this information at once can be a lot. So that is what led me to develop Riverside. This is just a quick diagram that I'll walk through of how Riverside talks, communicates, and how everything's kind of connected. So it is an agent-based tool. The agents are all written in Golang, so the entire backend is Golang. It's cross-platform compatible, and I've tested it on a variety of different operating systems and environments. But basically, the agents send all of their raw host data through gRPC, and I use protobufs in Golang to like actually make everything nice and neat so that the server can understand what it's seeing. The server then is also a Golang binary that simultaneously sends that data to the front-end visualization as well as stores it in a database so that you have the ability to actually go back in time and look at all the data that happened previously, because Riverside allows you to look at both real time as well as go backwards in time depending on when the data, what like time frame of data that you have. The front-end visualization will display the network data based on the time that you're looking at. And I also have a piece for session data that I have that you can like be able to log into like a server if you have multiple servers running. So you can have multiple sessions and be able to look at all of that. I handle all of the front-end stuff with WebSockets so that it's constantly updating. I do about a 2-second data batching, so it's as real time in terms of like, it has about 1 to 2 seconds that you'll see like time differences of once in a while. That's just to be able to batch the data all together that's happening like in that 1 to 2 second window and be able to put it on the front-end visualization. This is kind of an overview of what it looks like. This is something that I built starting back in probably August. This is like 6 months rapid development, got something working. It's definitely a work in progress, but this is the initial visualization that Riverside has. So all of the blue nodes that you'll see there are actually the agents. So those are agent nodes that are constantly being tracked, that have data flowing. And they connect to either other agents or remote nodes that are the gray nodes, things that they're talking to. So they're connected depending on when they communicate with other hosts. So the different colored edges are actually based on the protocol. So for example, the light blue color there is actually SMB. The dark blue color is HTTPS. Yellow is ICMP. And if it's gray, it's either just TCP, UDP, or the DPI library that I have just maybe couldn't fingerprint it at that time because it just doesn't recognize that application or that protocol. The bottom is the timeline that actually is kind of like the base of Riverside. So you're able to take that blue cursor, which is your cursor, and drag it either forward or backward in time and be able to like watch the visualization change as data is being flown into the server, as the agents are sending data, and as the front end is being updated automatically. I'll have a quick video and a couple slides that'll kind of show it in action. But that's the overview. You can pause and play the timeline at the bottom. You can fast forward to catch up to real time. So let's say you like went back a couple of days and you're like, okay, well now I'm gonna go look at what's happening right now. You can just click that. It'll bring you back to real time and fast forward the visualization. I think that's, yeah, that's all I'll talk about there. So I'll quickly show. So this is a quick setup demo that I have of just like opening the command line and being able to like run one agent and one server. So right now I'm setting up the server. All of the configurations for both the agents and the servers are handled with YML files. So like you can have everything in there. I have examples of like example configuration files on the GitHub, but those are just like some default stuff that I have set immediately. And now I'm gonna run the server binary. So it's gonna spin itself up. And it's just waiting now for host data. I already had the front end running. I'm just using a simple Python like web server in my command line, like that's it. I don't have it deployed on anything. But this is the option to like register or log into a server so that you have different like sessions or different servers running. You can like log into them and be able to look at different visualizations if you have other servers running and stuff like that. This is now the agent, same thing, .yml file, just having those configs, telling it what server you're looking at, being able to like tell it where you want the log file output, all that kind of stuff. And this is all just default stuff that I have set. You do have to run it with root for the agent because it is capturing like raw network traffic, so kind of same concept with like TCP dump or anything like that you have to run it with. Then the agent has a couple of different options. Listen is the default that I'll use here. That's like just to start capturing traffic. Ping is something that I added for like just testing that an agent's working that you can just run. But listen is the command that will actually allow you to start capturing traffic on that agent. And initially it'll ask you to have the server address and everything like that so it knows what server to talk to. If that's set in the YML file, it'll do automatically. You don't need to provide that in the actual agent start line. So it'll actually see the agent get entered, and then it'll start. And I have a database already running that's like collecting this, which is why it had that SQL statement for doing that. So this is the agent actually running right now. It's just a new Ubuntu agent. I was in a VM when I did this little test, but it's just capturing traffic. So you can see the blue cursor is going because it's keeping up with real time. We're just kind of watching. This is in a VM, so not much is happening right now. I think I Googled dogs, which is why you'll see like the HTTPS traffic come for the web pages and different things. I also then started opening like GitHub pages and like some other stuff to just start like triggering different traffic. But as you can see here, I paused the visualization. So the red line that's real time is still going, but I'm looking at a static point in time. So you have that ability to stop and like look at interesting traffic. You're like, oh, there's something that happened at this specific time that I want to go look at as an analyst. Let's say like an incident popped up and you have like an alert. You're like, I want to go look at this one point in time of like what was going on in the network at this one specific point in time. So you can go back to that time and look. And you have the option to like play with the time picker here that allow you to go like up by seconds, minutes, hours, whatever. You can do that manually if you want to just use arrows and stuff. Or you can have it then play from previous in time to actually watch from that moment in time how it progresses up. You don't necessarily have to go fast forward, but you can then watch from that point in time that you maybe had that indication that something weird was going on in your network, or you wanted to see what your environment looked at this point in time. So yeah, so let's switch back. So some of the things that I'll just talk about are like just some features of Riverside that I either built in or they're just kind of inherent in how I developed it. But it showcases both internal antenna as well as internal, external, so it kind of gives you that entire holistic picture versus something that maybe just shows what agents are talking to, but it gives you kind of that whole picture. As long as it's talking to an agent, it will show up on the visualization for Riverside, because it captures everything as long as there's an agent on it. So even if you maybe have a host that's unaccounted for that still talks on the internal network to another host that does, you would see that, and then that would be an indication. You're like, hey, that's another internal IP that should probably be an agent, and that kind of gives you the indication that maybe you have something that's not accounted for on the agents that you already have deployed. So metadata, like for a connection or a host, is shown by hovering. So on that, I had shown like a host. You can see all the interfaces. You can see its IP address and all of that. For an edge, you can see the two hosts that were talking, as well as over what ports, the number of packets that are being sent, as well as the start and end time. And the end time will keep updating with real time. If the communication is like continuous and it keeps going on, that end time will continuously get updated. I also allowed, this was something that after talking to people, I wanted to kind of incorporate some like user features that you could like change the visualization, so it wasn't just something that was like static and everything always looked the same. So being able to like change the shape of a node or add like a picture, because maybe that's like something that's like a computer that you know does this weird communication all the time, so you're gonna like label it or make it a different color so that you know when it pops up, that's something that you know it's okay. So you can change the labels on it. So here I changed the label to my host instead of the default, which is the host name. You can also change the colors of the different nodes. And for example, for this one, for remote nodes, if a communication is continuously happening on the network that you're on, the transparency of that node will actually decrease, kind of like making it like less noticeable, because that's something that happens all the time. So it's probably normal communication. So nodes that, or traffic that's like less frequent, those nodes will actually be like full color. So those would be something that you would notice more. So maybe some traffic or communication that's happening less frequently, or like something that's maybe anomalous on your network, is more noticeable for an analyst when they're looking at the visualization. As I said, links are, I use a deep packet inspection library to do automatic coloring of the different edges that are connected. If it can't immediately figure it out, it'll be gray. But here, the dark green is a cell. This is an HTTPS connection, and the purple is actually a DNS connection for these. And I try to, I correlate the edge width with the throughput. So if there's a lot of packets, like it's a continuous communication that's occurring, the edge will actually get thicker. And I'll show it in the video demo, like an example of that, where I have like a continuous RDP connection, like I'm connected to something via RDP, and the edge will just continue to get thicker because that connection is still happening, and I'm still connected to it. So it kind of draws your attention to the connections that are like continuous or last longer than maybe like something that's like a second, like maybe a DNS. Okay. So I'm gonna play, this is a sped up version of something that I did. So I simulated an attack scenario with Docker and had Riverside run on the environment. So I simulated like as if I was an attacker, ran a bunch of commands and stuff like that coming in. I like simulated brute forcing RDP into an initial host. I will show some like what is lateral movement technically. I use PSExec like SMB to a bunch of hosts. And then I used FTP to like take data off of one of those and then out to like an attacker IP. But it was like just simulation done with Docker, just kind of show how Riverside would visualize something like that when I was demonstrating it to other people. So here, the dark blue colored line is, or link is RDP. But as you can see, like this is like the example I said, I literally was just sitting there like brute forcing RDP connections, and I connected. And so that link will continue to sit there. I then connected, and then I just stayed on that host. And so I'm gonna fast forward real quick. Okay. So this is, then after I did that, I then used PSExec to like move to another host on SMB. The light blue is SMB. So I did that, and I did that throughout the network. So I kind of was just showing how Riverside can visualize that, where if you're moving through the different colored protocols, where the host will actually show that communication happening in real time. I also had a traffic generator running that showed like other traffic that was just kind of randomly happening on the network, but this is like the actual attack scenario that I built out where I did that. So, whoops, I don't know why I restarted, sorry. So something else was that I used, I used the coloring to kind of change the color of one of the hosts, because I was like, oh, this host is probably bad, because that's the one that initially RDP'd. So I colored that red, so that later on, when that host is communicating again, it pops up and it's red. So that I'm immediately drawn to my attention to like that node, because that node is colored differently. So as you're like doing an investigation or looking through Riverside, you have the ability to like change the colors of nodes, whether it's something that's like more noticeable for you, or the shape, or something that's maybe like better for you as an analyst to recognize on the visualization. Because again, that's the whole point of like the visualization, that it's something that you as a person can like actually use so that it's a useful picture for you. So that's another, so then I did the PS exec again from WS03 to WS02. I was using one host to do DNS beaconing, so I just had like little DNS beacons that were coming out, so that's what that one is. I then started changing all the colors of the nodes that were like compromised or that I was like investigating technically to orange, so I could kind of track all of those communicating. And then the last piece that I talked about was then I used FTP to just like move data from one host to another out of the network. And so that's what the orange line is. So that's just kind of an example of Riverside visualizing a very, 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 very high level like attack chain scenario of obviously not showing stuff at the host level like that, but being able to show something like an initial brute force attack over RDP, SMB lateral movement, and then data exfiltration. And being able to visualize all of that for someone, because being able to see how everything connects and how everything actually looks in your environment, I think is really important, and something that at my previous job, I think a lot of the groups and people that we worked with struggled with, and it's something that can be really useful, especially when you're talking with people that maybe aren't on keyboard all the time. You're trying to communicate to your boss or like to your other coworker, like why this is important and like why this is impactful, or just even explain what you're doing. Like, this is what it looks like. I colored these orange, like these, like, and being able to show like, this is what happened on the network. And I think that visualizations can have like a really powerful like effect for that. Just some recent updates that I did. I am in the middle of moving, so I haven't had as much time to devote to this since I finished my master's program, but I would like to keep working on this and keep adding stuff. So some recent things are that now you can actually just immediately grab the blue cursor and it'll pause the visualization. So like, let's say you're watching it in real time and you're all of a sudden like, oh, that was interesting. Instead of having to like go hit the pause button, you can just grab the cursor and it'll immediately pause that and allow you to move. And I also track like something that I realized it wasn't doing immediately was whatever host initially initiates the connection. I wasn't like making that apparent for people on the visualization. So like, it was always showing it from the agent perspective, but on the right, you'll see the picture. Like, this is an example where the remote host is actually the one that initiates the communication with the agent. So the true like source that like initiates the traffic is actually going to be shown on the left, and then the like host that's actually receiving that initial traffic will be shown on the right. So you kind of know like who's initiating that, who's starting that communication. This is just like some stuff that I put together of like things that I'm going to try and work on and incorporate, and just things that came out of like me doing my master's program and doing my research and stuff, and things that I think that are important for like visualizations in general, and things that could help, maybe not just with Riverside, but just in general with like adding to other visualization capabilities. Like, I don't think by any means that Riverside is like, you know, the best tool out there, but it's something that I made that I think will hopefully help other people maybe say like, oh, that would be really useful where I work, and either taking this and building their own, or taking what I have on GitHub and making it better. And yeah, so thank you for listening. If you have any questions, I'll take them. All of the stuff that I just showed is on my GitHub. Again, like, I've just put it out there as something that I made, but if you have any questions, I'll take them. Thank you. Stop. Okay, yeah. Yes, it's fine. I'm sorry, I couldn't.
Network tap port?
Oh, so right now, the question was, and please correct me if I'm wrong, the question was if I pull information from a network tap port right now? Yeah. So right now, the only way that data gets entered into the database is if you're running the agent will immediately collect all the interfaces that it sees on that host, but beyond that, I haven't tested it on specific instances like that you're talking about, which was like something that I got asked about previously, and I just haven't had the time to like test it on various environments and stuff.
How are you handling data import?
So that is something that I want to add, is being able to like take, like, let's say you have like a PCAP or something like that and you want to just upload it and see like, what does this look like, and be able to move through in time. I don't have that yet. Right now, I'm just running I was running a Docker instance of Postgres, and it just will create everything for you. I use Gorm, an ORM library, to like do all that in the back end, but past that, like right now I don't have any way to, I guess, like upload a PCAP or something like that and then be able to visualize it. It's on my list of like to do, because I do think that would be like really important, because like not everyone maybe has that running immediately, but yeah. Yes? So right now, the largest that I've tested it with on any of mine, because again, this is like all on like my little home network and stuff, is 30. I think that if we got into like the hundreds and the thousands and stuff like that, I would need to change some of the front end stuff so it like basically caches, so that the front end doesn't like slow down in that after that. Because I think when I did it with 100, after like 20 minutes, I noticed a difference. But depending on what you're, like when I put it on a droplet and like had better stuff than me running it locally on my laptop, I didn't notice any performance issues, but again, I haven't tested it like large scale in terms of like thousands or stuff like that, and I would definitely need to look at like changing the data views and like probably using some caching to do that for when you're going back in time in that. Yes?
Are you looking at, in the future, maybe Windows-based agents, stuff like that?
So right now it does work on Windows and Linux. I have the binaries pre-compiled. I've tested it on a couple different Linux flavors, Ubuntu, Kali, and Fedora, but in Windows. It works on Windows 10 and 11. I've tested them, and they'll all run together as long as they're all connected to the same server.
And is the agent lightweight?
It's going, so like as lightweight as a compiled binary can be, but I mean, I've run it on my laptop while doing other stuff, and I don't notice that my laptop's like I don't notice a difference. But again, like I would have to test it on larger like enterprise environments and stuff like that to know if it's like truly lightweight, I guess, in that sense. But I use like RPC and everything, gRPC, to send everything back and forth. So kind of like all the standards with Golang with the protocol buffers and stuff. Okay, I think that's it. I'm sorry. Thank you.